Hi, everyone, and welcome to our Qualcomm Dragonwing and Qualcomm Linux 2.0 release live stream, if you will. I'm David Tischler. I am a developer relations manager here at Qualcomm on the newly formed Dragonwing DevRel team. So you might have seen me previously from some live streams where I was wearing Edge Impulse attire, but today I'm in Dragonwing attire. I'm very excited actually to get out into the community and start engaging with developers. And Qualcomm Linux is one of the things that will certainly be showing off in the coming months. But today, with the release of Qualcomm Linux 2.0, we wanted to do a bit of an overview. And so I'm joined by Sandeep here, who you can see right above me on screen, who is going to be walking us through all of the new features, new capabilities, and open source contributions that we've made. I'm going to turn it over to you, Sandeep. I'm going to, in the next, I think we're scheduled for 90 minutes, but I've seen a few test runs of this, and I know that we were a bit over. So I've got my stopwatch ready. But we've got a couple of different speakers that will come on. I'll be introducing them throughout, but let's take it away, Sandeep.
Okay, cool. Thanks, David.
Yep.
Hey guys, good morning. This is Sandeep Batula. I am the software product manager from the Industrial Embedded IoT business group. So today I'm excited to present Qualcomm Linux 2.0 and what's new. Before we get started, what you see on the screen is important for you to understand the scope of this presentation. What you see is Qualcomm Dragonwing. It's a marketing brand for the industrial and embedded IoT product portfolio. So the scope of presentation is limited to this business segment. Okay, so today I will cover Qualcomm Linux 2.0, what's new. So I will start with product overview and lifecycle, and my colleagues will present the new open development model. And for the folks who are already familiar with Qualcomm Linux and the folks who want to get started with Qualcomm Linux today, we got both of you covered with, and we will present the migration to Qualcomm Linux 2.0. And we'll present the one software foundation where we support the multi-platform support and the SDK, how the edge inferences can be accelerated with our Qualcomm Intelligent Multimedia SDKs. And we'll do a demo on the Dragonwing. We'll show the demo videos on the Qualcomm Dragonwing IQ9 EVK. Okay, let's get started with the product overview. We want to start with what is Qualcomm Linux and why Qualcomm Linux. Qualcomm Linux is a single unified Linux platform purpose-built for the Qualcomm Dragonwing IoT SoCs. It is designed to support a wide range of products, ranging from edge AI cameras to industrial gateways to robotic system with a single software foundation. Qualcomm Linux is built on 4 key pillars. The first and most important is the open source foundation. Qualcomm Linux is built with the Upstream Linux and the community supported open source projects. And so this foundational software is used in our the Yocto reference BSP, and we have only one code base and with one kernel, one root FS, one BSP for all the Dragonwing supported Dragonwing SoCs. So what this means to you? So this means like you develop with one SoC and you can use the same software foundation across all the supported Dragonwing SoCs. So this prevents your BSP fragmentation and reduces the technical debt, and you can simplify your maintenance. And the second one is we on Qualcomm Linux, we provide standard open source tools, containers, IDEs out of box. This means you can accelerate your development and ship your products faster to the market. On Qualcomm Linux, we support modular. This is a new modular overlays to get the best performance from the Qualcomm SoC where your product needs it. What this means to you is you can still work with the open source foundation that we have built, and also you get the best performance of the Qualcomm SoCs at the same time. And the Qualcomm Linux is product ready, production ready with Edge AI. You can bring your models from PyTorch, TensorFlow, Onyx, and run the inferences on the edge across CPU, GPU, NPU with our Qualcomm AI Engine Direct QNN. And you can, what this means is you can scale your AI from one top to 300 tops with our Qualcomm Dragonwing SoC portfolio. Qualcomm Linux is secure by design with the built-in security from boot to app, and we provide SE Linux enabled distros and robust OTA updates and hardware-backed key management. This means that you can launch your product with the enterprise-grade security. Okay, so now let's look at what's new in Qualcomm Linux 2.0. So when we started Qualcomm Linux 1.0 in March 2024, the intent was to deliver a completely open source and Upstream-First Linux distribution. With the learnings from our developers and the customers with their production environments, the commitment is fully in execution right now with Qualcomm Linux 2.0. On Qualcomm Linux 2.0, we moved to completely Upstream-First development model with a public GitHub and OpenCI. This model is supported through a open source branch called Qualcomm Linux Mainline, where this is our Qualcomm development branch, and that's where this is the tip of our development. And we merge the code here, and we back propagate the changes from this mainline back to LTS branch, what we call as Qualcomm LTS branch, and where we plan for the long-term stability and provide the completely validated releases with the for the commercial deployments. Okay, Qualcomm Linux. Today we announced GA for Qualcomm with Qualcomm Linux 2.0 with the Linux 6.18 LTS kernel and Yocto project 6.0, which is Rhinos. Meta-Qualcomm is a Qualcomm Yocto project, and it is Yocto project compatible, fully Yocto project compatible. What does it mean to you? This means like your existing Yocto projects can scale with Meta-Qualcomm. And to complete the open foundation, we have public on-device and host tools for compilation, configuration, and building and profiling across multiple operating systems. Qualcomm Linux is deployment ready with a single kernel source, and unified device tree. This capability is achieved through the fit image based DT selection. This means you to support your board definition, all you have to do is update your DT selection and deploy. On 2.0, we support multiple boot options. We support UEFI, EDK2, and also U-boot. And on 2.0, you can add modular overlays on top of the open foundation. This modular overlays gives you new capabilities, new features that can be unlocked from our Qualcomm SoCs across multiple technologies: camera, audio, video, and graphics. As you unlock these new features and unlock the full performance of the SoC, you don't have to change the base source. All you have to do is like install these modular overlays, and you can switch between the upstream and these performance optimized overlays both at runtime and also build time. And we provide Meta-Qualcomm third-party public repo, which builds cleanly on Meta-Qualcomm. So as a BSP vendor, you can bring your hardware with Qualcomm SoC, and you can contribute to this Meta-Qualcomm third-party layer, and you can build with the same Meta-Qualcomm foundation. And we welcome all the developers to contribute to both Meta-Qualcomm and Meta-Qualcomm third-party. And Qualcomm Linux is deployment ready and enables enables OT and IT workload consolidation. For this, we enable KVM for you to safely run your isolated workloads as virtual machines. On Qualcomm Linux 2.0, similar to what we did on Linux 1.0, we will support full OST OTA and firmware updates through Capsule. And we will continue to do our quarterly releases, which has the features that are fully validated. And we have a major, this will be followed by a major release in 2 years with a Yocto upgrade cycle. And we support extended lifecycle for full SoC product lifetime, and we provide CVE updates on the Qualcomm owned components through the product lifetime. So Qualcomm Linux, the key takeaway is Qualcomm Linux is built for your use case. You use the single software foundation to build wide variety of products like Edge AI camera, where like on-device inferences you can do with the Qualcomm Intelligent Multimedia SDK, or you're building a product for industrial HMI with a stable display and hardened end-to-end security, or real-time control with deterministic scheduling with a native real-time, or a product with industrial gateway with Ethernet, MQTT, CAN bus, or industrial connectivity. Or even if you have same software foundation for the AMR robotics with ROS2 and Vision via Qualcomm Intelligent Robotics SDK. So quick visualization of what Qualcomm Linux, and to give you a full picture of what Qualcomm Linux is. So at a core, it is the base open source foundation, and there is and we provide standard boot options with the U-boot and UFI with EDK2, and standard firmware artifact and hardware configuration management with Linux firmware and DTB overlays and fit images. And we provide industry standard frameworks to get to your application faster. And like I said, you can install the overlays where your product needs the additional the required performance. Throughout this developer journey, we support we go through like open development workflow, and we support the developer ecosystem with containers, tools, documentation, and sample apps. And we are building even stronger partner ecosystem with our preferred vendors and partners who support our industry protocols, and partners like Canonical for more Linux distributions to support like Canonical Ubuntu. And throughout this, as you scale, we support security and compliance, and we support the software. We have a clear, predictable software release cadence, and where you get the continuous CVE updates for maintenance, and also we have a software cycle like aligned with the SoC product longevity. And we to get your application faster and unlock the full performance of the full capabilities of our SoC, we provide SDKs with the Qualcomm Intelligent Multimedia SDK and the Qualcomm Intelligent Robotics SDK. Okay, so quickly on how we support the what is our software lifecycle plan that is aligned to our SoC product lifetime. So typical product longevity of our SoCs lasts for 10 to 15 years. We have planned to support our Qualcomm Linux software aligned to this product longevity program. You will see two key phases. in each major cycle, and each major cycle lasts for 2.5 years. And you see a development phase and a standard maintenance phase. Development phase is when you will, so we will continuously roll out the new features quarterly, and the standard, when I say roll out the features, like I mean it's a validated features. The features are the continuous development in public GitHub, but these quarterly milestones are for the fully validated features. And the standard maintenance, we support standard maintenance, which includes the bug fix and security. And the major release, we make sure they overlap so that you have a clear migration path. And also each cycle lasts for the software longevity. And and Qualcomm provides security and CV updates on the Qualcomm Dragonwing components. So we'll support the security and CV updates on the Qualcomm components. On the release cadence, so with Qualcomm Linux, you get a predictable release cadence. So you can see this. We launched the Qualcomm Linux 1.0 in 2024 March with 1.0, and we've been doing the quarterly releases continuously with new features, bug fixes, and security updates. So 1.0 we released with Yocto Project Kirkstone 6.6, and and then in 2025 we upgraded Yocto to Yocto SCARCAP and kernel LTS kernel with LTS kernel 6.6. And yet now, like with 2.0, we have we are releasing the Yocto 2.0, Qualcomm Linux 2.0 with Yocto Project Rhinos with 6.18 kernel. So moving forward, you will not, it doesn't reflect in this slide, but moving forward, we plan to do the major upgrade cycles every 2 years, aligned to the Yocto upgrade cycles. And we'll continue to do the quarterly releases on 2.0 and followed by major upgrade cycle in 2 years. So to give you the picture of like what are the supported Dragonwing IoT SoCs on this Qualcomm Linux. So on 1.0, like we supported QCS 6490 and QCS 5430 and IQ 9075 and IQ 615. And then also we also supported IQ 8275. Moving to 2.0, we will have the parity, the parity with the same SoC supported on 1.0. We will support the same SoC, and we will incrementally, you can already see we are supporting IQX, and we will continuously add more Dragonwing SoCs to this roadmap. So you will, with Qualcomm Linux, you will get a clear OTA migration path from 1.0 to 2.0 and 2.0 to the next major upgrade cycle. And this is a unified baseline across SoCs, and this is a true software foundation to build once and deploy across multiple tiers, from entry-level tier to the premium tier. So lastly, like a quick snapshot of what our typical SoC product longevity program looks like across different SoCs. With that, I will hand over to Kim.
All right. Thanks, Sandeep.
Hey, David.
I'll actually introduce Kem Raj, who's going to go over the open development workflow. And Sandeep, I was timing you. I think you went 1 minute over. So Kem, you've just lost a minute. You're going to have to, I had you allocated for 5, but I think I'm only going to be able to give you 4 minutes. I don't know. We'll see.
Yes.
It's all right.
Thank you. Hi, everyone. So we're going to talk about open development workflow today. So with QLI, open development workflow is a collaborative and transparent approach for building software where the entire process from idea generation to release is conducted openly. and it involves contributions from broad community. So with Qualcomm Linux 2.0, the development of Qualcomm Linux is fully open. And as you can see, development has moved fully and it's hosted on GitHub. If you are a Qualcomm Linux developer, you will be reviewing and contributing changes to repositories directly on GitHub. You will be able to follow the development, release process, and all incoming commits directly on GitHub. The Qualcomm Linux repositories, as they happen, and participate in reviews and discussions and provide your feedback right there. The CI pipelines, everything is all in open. So they are triggered on every pull request and results are attached to PR commit trails. So everything is auditable. You have full visibility into the commits and the builds and tags and releases. I've given some links here. You can go and browse those on GitHub today. And you can also look at the existing work and the PRs that are opened and also issues and everything you do on GitHub. It's very similar to that. With this, what we have done is, I've covered a couple of components. Qualcomm Linux stack includes many components, but Linux kernel is one of the common components that is developed and is very key. So I'll go over what we are doing in there. As you can see that we have the Qualcomm Linux 2.0 Linux kernel is also hosted on GitHub. It supports a mainline, which is called Qualcomm Next Branch. It is modeled on master next branch of Upstream Linux kernel, very similar to that. And all our release branches, which is 6.18 right now, they are cut out of that. And all the fixes for the release branches flow through the mainline. Single kernel image for all Qualcomm target with fit-based and device-free bindings selections is part of it, which makes it easy for you to customize, add features to the kernel, and it supports KVM as default hypervisor. And the real time is used from Intree, the support that has been added for ARM64. So we've tried to utilize as much upstream features as we can. Meta-Qualcomm maintains the kernel recipes. So if you're building it as part of Qualcomm Linux, then the recipes would be in Meta-Qualcomm. And similarly, the real-time recipes will be there as well. And if you're just a kernel developer, you could just look at the kernel sources. I've given the links there on the side. You can look at particular branches or you can look at the main line. So this is the flow of patches. As you can see, all development happens on the main line and all developers engage there. And after the releases are cut, the fixes flow into the release branches. They are cherry picked and tested as they become available. And this continues on, and all the development happens on the Qualcomm mainline. Similarly, the second thing I'll cover is Yocto project, which is the distro builder that will build the platforms on for Qualcomm Linux. And with this 2.0 release, it is based on Yocto project LTS 6.0 release, which is codenamed Rhinos. What it all provides is there are primarily three components. There is a Meta-Qualcomm, which is a BSP layer, and there is a third-party layer called Meta-Qualcomm third-party, and the reference distribution layer that we built together. All these layers are again hosted openly. You can check out the distro layer, and you can build any of the platforms there. And as you can see in the picture, there are additional layers that are provided, which we are testing to test certain additional stacks. And you could build multimedia images. You could build command line images. Those are all references Load provided. And they are, these layers additionally, as you can see, are fitting in those. The Meta-Qualcomm third-party layer hosts additional layers or additional BSPs that are built by the ecosystem for based on Qualcomm platforms. And similarly, the Meta-Qualcomm will host all the Qualcomm platforms and all the BSPs now, and also any new BSPs or new products that come out will be hosted there. So we welcome you to participate with us on GitHub directly. It is Upstream-First and open development model. You can see all the changes happening directly in Upstream repositories, or you can work with Qualcomm Linux directly on GitHub, and all the build instructions and all the processes are followed on GitHub. Thank you. So see you on GitHub.
In 4 minutes. Great job. All right. Thanks, Kim. I might have been on mute there, but I appreciate you getting it done in 4 minutes exactly. I was timing. Not exactly, but all right. Next up. Now, you just started to talk about a couple of things there, Kim, that were pretty important, which is the Yocto layers themselves. Next, we've got Saurabh Banerjee joining all the way from Hyderabad. And Saurabh, let me see if your camera works. I know you were having some difficulty earlier.
David,
okay, this will.
Difficulty still exists, so we'll go only with audio.
Okay, no problem. Audio will work. And thank you very much for joining. And go ahead, take it away.
Okay, thanks, David. Good morning, good evening, good afternoon, everyone. So today I'm going to talk about all the users who have been using Qualcomm Linux 1.0, how they can migrate to Qualcomm Linux 2.0 in this journey of the product that you're building with our software solution. So in this first key change that I'm going to talk about is the build system itself. And this is a significant improvement, a change. We have migrated to use CAS earlier in Qualcomm Linux 1.0, where we used our own shell scripts. Instead of that, we have moved to CAS-based build system, and CAS is a YAML-based orchestration mechanism to manage builds and machines and distros, and it makes it much more easier. And beauty of CAS is it is a community tool, so you can use it even in your other solutions. And CAS is a single tool. It would handle the sync as well as a big build execution for you. And thus, it's the one place where you could use it for everything that you need to manage your BSPs or the distros for build invocation. CAS is a specific feature which we know as log file. And the key benefits of log file are every layer that is part of the Qualcomm Linux build is pinned. That means the specific revisions from those layer repositories are pinned in a YAML file, and that helps to provide reproducible builds to all the users of Qualcomm Linux, whether it's a community developer or Qualcomm itself. And thus, we are all working and sharing on the same release milestone that we have here. And one key factor is CAS is a containerized build environment, so this is perfectly suitable for setting up CI/CD. So let's understand what kind of impact to developer touchpoint it brings. It brings significant amount of improvement in how you would set up the CI/CD pipelines, because it's a standard tool. It is much more conducive to be used in CI/CD. And the machine distro vars, all the environment variables that are required to be used. They're part of the YAML files that we have defined. You would find machine YAML and distro YAML files under Meta-Qualcomm's CI directory. And all the variables that we need for setting up the environment are defined there. One of the key things that have changed here in terms of build is our reference distribution layer, Meta-Qualcomm distro. Both the mainline as well as the LTS branch that we have two images now. The Qualcomm Multimedia image, which includes the upstream components. And then on top of that, we have the Qualcomm Multimedia proprietary image, which extends the Qualcomm Multimedia image by adding Qualcomm proprietary components or Qualcomm stack for respective solutions. A quick look at how one should use CAS. You can see here on the right hand side, if you intend to build, you can simply say CAS build and the YAML files that you want to use. Or rather, if you would like to get into a shell and do some experiments before invoking builds or change some things before invoking build, you could pretty much use CAS shell and the machine file and distro file, and then go ahead to run the bitbake command for the build. Next significant change with Qualcomm Linux 2.0 is device tree and DTB metadata management. So we have adopted a significant enhancement here, which is the flattened image tree. You see abbreviation here, FIT. The key thing to be noted here is in Qualcomm Linux 1.0, we used to have concatenated multi-DTBs. That means we would build the DTBs and concatenate them. That's what was loaded. But now we have replaced that with a flattened image tree based structure, and all the DTBs that are built for a machine and even the DTB overlays, they're part of this FIT file, thus aligning with a very well-known community standard when it comes to defining as well as managing the device tree. Also, in Qualcomm Linux 1.0, we used to have build time management of the DTB overlays. We would use specific variables to build the DTBOs and merge them into the DTB that we want to use. We have moved away from that because now with the flattened image tree file that we specify, the ITS file, the DTBOs can be specified as a specific node in the ITS file, and then they can be selected at boot time. So all this structure of the selection of the DTB and DTBO, we have defined metadata to identify the SoC board and subtype, and the SoC board and subtype combined together to define compatible strings, and the compatible strings are mapped to the DTB and DTBO that should be loaded at boot by UFI. And when we are talking about UFI, what we are using in UFI is a generic fit parser, which parses the fit it finds at boot time and matches using the compatible string that we just discussed, and loads the correct DTB and applies the right DTB overlay that is required for the solution stack. On the Yocto side, to manage all these DTB and DTBO combinations and to map them to the desirable compatible strings, developer can use this fit DTB compatible tuples, which are defined in one of the INC files in Meta-Qualcomm, and that's something that helps the developer to define what sort of compatible string maps to which specific device tree binary. What developers should be aware of now, to select any DTB, there are no specific firmware changes required. It's a very, I would say, malleable system. You just work with the ITS file, define the compatible string and the DTB and DTBO that you need to select, and UFI would match and load the right DTB and DTBO at boot time. And certainly because we have fit DTB compatible and Qualcomm DTB metadata act as sort of build time validations, these kind of there could any kind of metadata mismatches are also protected against. How to use? So we have these variables fit DTB compatible in the INC file that I mentioned earlier for the Yocto based workflow. Also, for easier suitable quick workflows, we have a standalone way to build the fit image using MKimage, and that also can be done separately by developers to quickly iterate through the DT changes that they're making as part of their experiments. Moving on, we have also significantly enhanced the way we manage the firmware. Now with Qualcomm Linux 2.0, all the firmware that we have for our SoCs are upstream to the Linux firmware repository, and the recipe for the firmwares that are part of the Linux firmware repository are hosted in OE core, as well as the Meta-LTS mixins for the Rhinos. So OE core represents the recipe in the mainline, whereas Meta-LTS mixins has the recipe for the Rhinos or the QLite 2.0 branch. So in both cases, whether it's our mainline development or our LTS development with QLI 2.0, we have an upstream aligned philosophy when it comes to firmware management and the firmware recipe management. All the packages that are defined by these firmware recipes are included in the image that you are building via the machine configuration files that are in Meta-Qualcomm. You can go and inspect the machine configuration files and see the packages expressed here in the machine configuration file. All our engineers actively contribute to the Linux firmware repository and the OE core packaging. Thus, we managed to keep a very upstream oriented firmware management strategy. And apart from the Linux firmware for boot and firmware for Hexagon DSP binaries are also posted in an open forum. There's no login required, and recipes for those are also available in Meta-Qualcomm. So key changes that developers need to be aware of. So you don't need to maintain any sort of BB appends in your BSP layers, or you don't need to rely on Meta-Qualcomm HWE from Qualcomm Linux 1.0. There's no separate recipe because we have everything, as I mentioned earlier, in the OE core and Meta LTS mixins. And there are no more downstream recipes for graphics firmware or video firmware because everything comes from the true upstream source. Now, in terms of using, if you are defining your own machine and you would like to include some firmware which is specific to our SoC, you can look at Linux firmware, or you can even take references from the machine configuration that ran Meta-Qualcomm, and you could define the same packages in your machine, thus benefiting the same way that our reference EVKs have. And all the firmware are installed on a standard path, user lib firmware. There are no custom paths where we are installing the firmwares anymore. Now there's a slide on UTA and software upgrades. So for the over-the-air upgrades in Qualcomm Linux 2.0, migration from 1.0 to 2.0 over there is possible. There are upgrade paths that exist from our certain 1.x releases to 2.0. And the over-the-air upgrade still uses UFI capsule for managing the firmware upgrades and OS tree for the Linux parts, the EFI and the rootfs, which is same as 1.0. So we have maintained compatibility there as well. We still do atomic version controlled updates with ability to roll back, and systemd boot counting manages the boot retries and auto rollback. So one could compatibly move from a 1.0 to 2.0 release. There's some things to be aware of though. What UTA on field would not do if you have a 1.0 device, for example, with a specific partition size or a partition label or even a specific GUID, that is something that cannot be changed over UTA, because these kind of operations could be quite risky for the device. So when moving from 1.0 to 2.0, one should bear in mind that these are the kind of things that should not be changed in partition table. And we in 1.0 we had a custom UFI sec application which would store some variables in RPMB in terms of boot counting. Those are removed and we have aligned to a more upstream aligned way in 2.0. And this is taken care by the upgrade when you move from 1.0 to 2.0. And how to use it is very straightforward. The capsule should be staged or copied at boot/IFI, and the OS indications variable is set in the IFI-var, and then eventually OS3 admin deploy command should be run, and you reboot and you get to the newer 2.0 software. Yeah, thank you. Back to you, David.
All right. Thank you, Saurabh. Next on the agenda is going to be Srikanth Kata, who's going to go over a system overview guide and the one software foundation here. I think we're going to be covering topics like boot, security, KVM. Let's have at it, Srikanth.
Hey, thanks, David. Hello, everybody. Today, I'll be taking you through a high-level overview of our foundational software architecture that we put up with Qualcomm Linux 2.0. But before we get there, let me just remind you with a couple of challenges that we saw with our Qualcomm Linux 1.0 offering earlier, where we enabled two separate static build configs, one for open source and one that supports downstream proprietary value additions. With that approach, we had to bring in support for 2 static builds, one for open source, one for proprietary. The updates across security or LTSS were duplicated. Even the validation efforts kind of doubled. All in all, incurring a parallel maintenance across product lifecycle. End result, we were carrying a high technical debt that multiplied with each release and with each SoC that was getting added to Qualcomm Linux. With 2.0, we have resolved these challenges. Let me share you how. So as can be seen with 2.0, we have a single unified software base built with the latest and greatest kernel and Yocto LTS releases. The SoC features and the device drivers are supported with upstream code merged into the community maintained projects. The complete software, the complete software includes open source software components across multimedia, connectivity, and open source AI framework and tools like the likes of LiteRT and Onyx Runtime. And with the Qualcomm Linux 2.0 open development model, one can find all the projects that are part of this base foundation out there in public GitHub. And in addition, we also deployed the open CI/CD to ensure the sanity checkers are in place for every commit that makes into these Git repos. In addition, we also added support for open source hypervisor called KVM, which is a kernel-based virtual machine, which was non-existent in our 1.0 releases, where we only supported an in-house hypervisor called Gunya. And with KVM, we also enabled virtualization of all subsystems through the host operating system, and are now working towards enabling para-virtualization of all the subsystems, which is coming soon. We also added support for multiple bootloaders. This includes end-to-end open source boot flow with U-boot, along with EDK2, which is our default bootloader. We also brought in support for our multimedia SDK as part of the base foundation for the very first time, which was again non-existent in our open source variant on 1.0. We enable this to ensure the sample application development workflow is provided on top of even the base foundational software. All in all, this is all our upstream construct, completely aligned with open source. Now, what we did with our proprietary value-added components. Now, we also brought in support for these proprietary value-added components through a concept called discrete modular overlays, which extend our base foundational software to fully make use of the hardware capabilities. So what are these overlays? These overlays are a set of discrete modular packages consisting of downstream proprietary kernel and user space components that can be installed at runtime on top of the base system that we just looked at, which will seamlessly enable hardware accelerated features without requiring to rebuild or reflash the images. These are fully decoupled from the base foundational software. As can be seen, these are fully decoupled from the foundational software and enable pure plug and play functionality, providing true modularity and ability to customize based on the product needs. One can pick and choose the components of interest and ignore rest of the packages if your product doesn't need it. So if a product is only looking for a high-end camera functionality, you can just install the camera package overlay and ignore rest of the packages and get going with your product. These overlays greatly simplify build and maintenance by eliminating multiple fork of the projects, duplicate build workflows, and by supporting multiple product SKUs from the same base foundational software. You can build industrial products, you can build AI products, you can build camera products based on the same foundation by pick and choosing your packages of interest. And this cleanly aligns with our Upstream-First strategy, which we adopted when we embarked on this Qualcomm Linux journey. While the foundational software remains pure upstream, any downstream value additions can be brought through these discrete modular overlays. And as can be seen here, we have brought in a full-blown support for multimedia and AI acceleration through these overlay packages. And all of these software constructs, including the base foundation and the overlays, are all designed around clean Yocto-compatible BSP layer Meta-Qualcomm, which is a Yocto project certified, which demonstrates a strong Yocto compliance and an architecture alignment with the upstream community. And as Saurabh was alluding, we support over-the-air upgrade to 2.0 images from our earlier generation 1.x line of images seamlessly. We can do a selective firmware updates through UFI capsules. We can do a full-blown HLOS only update through the upstream OS tree, or a full over-the-air update of the entire images with a rollback mechanism in place. So all through this re-architecture to support overlays on top of the base foundation, we ensured the developer touchpoints remain intact, in turn enabling developers, customers, product owners to seamlessly migrate their product layers from 1.0 to 2.0. Barring a minor change, again, which is towards aligning with upstream, wherein we brought in support for GLVND, which is a graphics vendor abstraction layer, which sits between the graphics applications and the vendor-specific graphics implementations. And on the usage part, we have provided plenty of publicly accessible documentation on how to create these base software images, how to create the overlay packages, how to install these packages, and get going. We also have provided means to wrap everything, including all the overlays pre-installed into a single image, and provided provision for the same for a quick out-of-box experience. Before I conclude, just wanted to say that we are really excited to have you all join us as part of this Qualcomm Linux journey. Thank you. Over to you, David.
Thanks, Srikanth. And I think that places us on to our last speaker, who is Amit Mate, and he's going to show off an example, a sample application of our new AI SDK. Let's have you take it away, Amit.
Yeah, thanks, David. Can you hear me?
Yes, I can.
Yeah, hi, this is Amit here. I'm a director of product management here at Qualcomm, responsible for AI SDKs across industrial, IoT, and automotive. And today, I would like to introduce you to the Qualcomm Intelligent Multimedia SDK, or IMSDK, as some of you may know it. So it's an SDK that lets you transform this highly capable QLI 2.0 platform into any connected intelligent product that you can envision without having to start from scratch. So hundreds of products have been built and launched using the Qualcomm IMSDK across 16 plus product categories. Companies like Samsung, Amazon, Bose have built AI-powered cameras, drones, robots, and speakers using this. So it's a single SDK that lets you build across any Dragonwing chipset. So the IMSDK itself comes with a rich set of ready-to-use hardware-accelerated features and product blueprints. It provides a user-friendly API so you can invoke this hardware-accelerated functionality such as video encode decode, CV algorithms, ML runtimes, and much more. So essentially, what the IMSDK enables you to do is build faster, integrate smarter, create performance-based differentiator for your products, because it's still based off of GStreamer and zero-copy architecture. And it also helps you to scale your product faster because the product is built on IMSDK, which is a production-grade SDK, and is trusted by many in the industry. Now let's take a look at what is new that we're bringing in IMSDK with QLI 2.0. So we are introducing a new Python and C++ pipeline API, which lets you construct an AIMM pipeline with much fewer lines of code. So if you remember previously, if you had to construct an AIMM pipeline, you would require in-depth knowledge of GStreamer and about 2,000 lines of code to construct a typical pipeline. But with this new API, you can construct in a few hundred lines of code. It becomes very modular. You can easily maintain it and extend it. Another new feature that we're bringing is an API for all the standard AI runtimes through IMSDK. So essentially, you get access to LiteRT, LiteRT-LM, ONNX runtime, Execute Arch, and our own unified cart. So essentially, you can take any compatible model from open source like Hugging Face, and as long as the model fits the compute storage memory budget of the underlying Dragonwing chipset, you are able to use it and combine it across runtimes to build your AI pipelines. And not only that, we are also providing highly optimized models on AI Hub for the Dragonwing platform, which can be incorporated into these AIMM pipelines. So another new thing that we're doing is we are up-leveling a lot of our sample apps in line with the industry. So most of the sample apps now will be microservices based and containerized. So you get access to LLM, VLM based microservices, which you can incorporate in your products and use them right away. Or you can look at the blueprints like audio analytics, tripwire, and many more, and kind of construct your applications based on that. So essentially, this set of sample apps gives you access to a whole lot of latest Llama, Gemma, and Quen family of models, which can be integrated very easily in your apps. Another thing we are doing is we are actually also providing coding agent skills, so which lets you basically use your favorite coding agent and construct these AIMM pipelines now within minutes. And essentially, that is what we are bringing with the QLI 2.0. And you still get all these features that already exist in IMSDK, right? So I'll give you a moment to kind of look through the slide. Essentially, it tells you that we have about 300 plus GStreamer plugins, 250 are upstream, and there are 50 hardware accelerated plugins, which we are committed to kind of make it upstream in the coming releases. And you get the all the hardware optimized plugins across different IPs: camera, video, audio, graphics, display, and essentially all the IoT protocols from Kafka, MQTT to Redis, all the way to support for streaming stack like WebRTC, HLS, and RTSP. And as you can see on AI Hub, we have 85 plus AI models, many of which have been tested with the sample apps. So you get access to all of that. And essentially what we're saying is you can build advanced sports cameras, IP dash cameras, drones, robotics very easily with the sample apps and the APIs that we provide. Now, as a developer, when you're using the IMSDK, the API that we provide, which is in C, C++, and Python, is your touch point, right? And what this AIMM pipeline comprises is, as you know, there is a source where you have a sensor source like a camera or audio, and you kind of pass it through multiple pipeline stages like hardware accelerated decode, pre-processing, inferencing, all the way through encode and through IoT message brokers to the sinks, which are like display and other modules. So in terms of source, we let you actually choose a camera type as well, right? Like we support out of the box RTSP cameras, ISP cameras, USB cameras. And once you kind of very easily configure your decode module to connect to that source, you can pass it through this pre-processing batch module. And then AI inferencing will let you mix and match all the different runtimes that we support now. We also let you kind of run it on any of these backends, depending on the model and the kind of workload that you have. So you can run it on NPU, GPU, and CPU very easily with easy configuration. And then again, we pass through this pipeline and kind of construct the AIMM pipeline that you typically do. Now, with this background, let me walk you through some of the sample apps that we have built and what they can do for you, right? So essentially now with the Qualcomm IMSDK, we are introducing this new documentation, which is very user-friendly, and you can go through this yourself. I think we have listed all these different AI pipelines. We have a tab for IMSDK plugins. So if you're already familiar with the plugins or you know which type of plugin you need, you can go there and kind of access it. We also have blogs for different sample applications. And one of these is a restricted zone and PPE compliance app. So you can see here, there is a nice blog to help you understand, how the pipeline is constructed, what are the different stages, how is it kind of parsed, and then you can also see this in action, but deploying our sample apps very quickly with a single click. Similarly, for the restricted zone violation, there's a nice blog. It walks you through all the stages, shows you all the pipeline construction. You can use this as is, or you can use our agentic tools to kind of modify it to fit your use case. And as you can see here, it's real time. It works on multiple objects at the same time. And this is ready to use for deployment as well. And you can construct like more innovative apps like this hand gesture, where you can actually have two stages, one for palm detection, one for hand landmarks, and then you can see how it operates in real time on the camera itself. And then you can do this palm-based embedding and then also classify what is the action going on, all in real time. This is another example where we show 32-channel AI inference on IQ9. So mind you, this is 32-channel of 1080p, and this is how fast it runs in real time, right? So this is for you to kind of just take a look at, modify it, download the models from AI Hub and productize it, right? Not only that, we also kind of support audio classification as one of our sample apps. You can, go through various kinds of sounds and combine it with, other apps to build your application. We also support concurrent vision and VLM-based demos. So the top half is kind of based on VLM. The bottom half is kind of based on, the typical vision application. And as you can see, all of this is running on a single node, all in parallel, if you can leverage the API that we provide in IMSDK. So essentially, that's all I had, folks. David, hopefully we're doing good on time here.
We are, in fact, doing good on time, because I was under the impression we had 90 minutes, but it turns out it was only 60. And so we have indeed made it with 2 minutes to spare. So we did great. We covered a lot of information in this webinar. I know that there will be follow-up questions. By all means, just reach out to us. I think that about covers it, though. Be sure to check out the Qualcomm Linux documentation. Be sure to check out the IMSDK documentation that Amit just showed. I've reviewed that. It's superb. There's also a new Dragonwing focused documentation site that has just launched today. Very simple, dragonwingdocs.qualcomm.com. Have a look there. And I think that's going to do it for us today. I noticed some requests for an Edge AI webinar. So along in the background, while we were chatting, we'll do something related on these, these EVKs in my hands, and do some AI deployments on Dragonwing devices in the near future. So be sure to follow, like, subscribe, click any bells, whatever platform you're on, and we'll see you on that one. Have a good one, everybody.